Hello everyone, welcome to my channel. Today we will discuss Leetcode 662, which is maximum width of the binary tree. So let's read the question. Given the root of the binary tree, return the maximum width of the given tree. It is saying that you will be given the root of the binary tree and you have to return the maximum width of the given tree. And the maximum width of the tree is the maximum width among all labels. Means you have to return the maximum width among all the labels. The width of one level is defined as the length between the end node, the leftmost and the rightmost non-null node, where the null node between end nodes that would be present in a complete binary tree extending down to the level are also counted into the length calculation. It is guaranteed that answer will be in the range of 32-bit signed integer. So let's see the example. Let's understand it with an example. Okay. So this is the given tree, and you have to tell the maximum width. So in this case, in this tree, you can see maximum width is at this level, and it is saying it is 4. How it is 4? So the starting node is here for this level. Starting node is here, and ending node is here. So width will be the distance between these two nodes. Also considering all the nodes between null and non-null node between these two nodes. Okay, so it is 4. How it is 4? You can see that it is 1. This is second node, and there is a there. Suppose if there would be a node, currently it is which is null. Okay, so it is 3 and it is 4. So it is the width is 4 because distance between this node and this node is 4. Okay, now let's see the next example. Yeah. Next example is this. So in this also, suppose if here, so this is the node 3 and this is node 2. So it is having one child and it is also having one child, and there is a null node. This is also a null node. Okay, and it is also having one child. So its right is null. So if if this is a node, then it will have two child and it will also have two child. So if we see this level, so what is the distance between this two, this node 7 and node 6? It is 1, 2, 3, 4, 5, 6, 7, and that is our output. So this we have to return the maximum width of the tree. Now let's discuss the approach, how we can do this. Okay, so for doing this question, you need to have understanding of the array based tree. Means if you are given a tree like this, how we can represent that in the form of array? If this is 1, 2, and 3. So if you consider this tree, how it will be stored in the array? It will be like this. If the root is 1, then root will be here, and its left child will be at index 2 into I, which is the index of this root node, I plus 1. and right child will be at index 2 into I plus 2. So currently for this one, uh, index is 0. So 2 into 0 plus 1. So its left child will be at index 1, and right child will be 2 into I plus 2, which is index 2. So this is the array base representation of tree. So doing this question, you must have knowledge of this array base tree. Now let's discuss the approach. So what we will do, we will simply do a BFS, and in the queue, while putting it in the queue, I will push this node along with the index, along with the index it will have in the array. Okay, so it is root, it will be at the 0 index, and its left child will be at 2 into I plus 1, 2 into I plus 1, and its right child will be 2 into I plus 2. Okay, now if I will be processing this level, while processing this level, uh, I will calculate the width of the tree. How I will calculate? Uh, at this level, what I will do, I will take the first node at this level and the last node at this level. Currently it is 2. We will see in this level also. Okay. So currently it is, so we will, how will calculate the width? We will take the difference between their index. So index of this node is 2 into 2 into I. It will have I is 0 for root. So it will have index 1, and it will have index 2, because parent is 1 and I of the parent will be 0. So 2 into 0 plus 2. So in the queue, it will be like this: 3 comma 1. 3 is the node and 1 is the index. And another will be 2 comma 2. 2 is the node and 2 is the index. Okay. So now while processing the next table, I will take the first node of the level and the last node and will check the difference between the index. So last node index is 2 and first is 1. So 2 minus 1 is 1. I will take a variable. Suppose I'm taking width. Width. I'm taking width. So I will store it. I will store this 1 into this. And each level I will maximize this. Now I will take one a node one by one and process the child. So 3 is having 5 as the child. Now I will push this into the queue. So what I will push into the queue? I will push into the queue 5 and the index. So what will be the index? So index for this 3 is 1. So what will be the 5 is its left child. So index for this will be 2 into 1 plus 1, which is 2, which will be 3. So I will push 5 comma 5 comma 3 into Q. 5 comma 2 into Q. Yeah. Sorry, 5 comma 3. And this will be removed. And it don't have any right child. So it will move to the next node in the queue, which is 2. So this 2 don't have any left child. It has right child. So index of for 2 is 2. So its right child is 9. So for pushing this 9, I will push 9 comma, and I will calculate index for 9, which will be 2 into 2 plus 2, as it is right child. So 4 plus 2. 4 plus 2, which is 6. So in my queue, it will 9 comma 6 will be pushed, and this will be popped out. So we have processed this level. Now we will process this level. Let's see. Let me clean the area. So in my queue now, I have 5 comma 3. I will take this 5 comma 3 out. And yeah, before that or any time, we can uh, calculate the distance between the first and last node. So first node is 5 comma 3 and last is 9 comma 6, which is 5 and 9. So we will calculate the distance and we'll maximize our width. So ninth node is at index 6 and fifth is at 3. So 6 minus 3 is 3. So our width increased. So I will change my width to 3. And we will start processing this. So we will take out 5 comma 3 and we can see it has only left child. So 5 is having index 3. So in our queue, I will push 6 comma and index for this will be 2 into 3 plus 1 as it is left child. 2 into 3 plus 1, which is 3 to 6 plus 1, 7. 6 comma 7. So I will push 6 comma 7 into my queue. And this 5 comma 3 will be popped out. And it and next will be I will take the next element, which is 9 comma 6. So 9 comma 6. So 9 is also having only left child, so it will push into the queue. So index for this will be 9 is having 6. So it will be 2 into 6 plus 2, plus 1 as it is left child. So 6, 12 plus 1, 13. 13. So in our queue, I will put 7 comma 13. 7 comma 13. And this 9 comma 6 will be popped out. So we have processed this level, and till here we have with our width equal to 3. Now we will process the next level. Let me clean it. Yeah. So in the queue we have 6 comma 7. So we will take this out. Yeah. Before that, we will calculate the distance between the first node and the last node uh, of the tree. So it is 6 is having index 7. 7 is having index 13 and 6 is having index 7. So 13 minus 7. So our width will be 6. With some, I think something went wrong. Wait 1 minute. This is 13 and 13 minus 7, 3, 3, 6. Oh, wait, this is having index 1. This will have, sorry, 0. This will have 1. This will have 2. And this will have 2, 2, 4, 2 plus 1, 3. This will have 2, 4 plus 1, 5. This will have 5. So this will have 2, 3, 6 plus 1, 7. And this will have 2 into 5 plus 1. Wait, sorry, 2. 2 into 2 plus 2 into 2 plus 2. The plus is taken. It will be 6. And it will have 2 into 6 plus 1. 13 is 6. Oh, sorry, sorry. Uh, Our width will be 13 minus 7, 7 plus 1. Because we need to include the node also. Okay. So we need to do a plus 1. So it is 13 minus 7, which is 6. 6 plus 1, which is 7. So our width will be 7, which is the maximum. So this is the logic. Uh, now time complexity for this time complexity for this will be O of n, where n is the number of number of nodes. So let's see the code. Let me clean the screen. Um, yes. So this is the code. So you can see that I have taken a queue, and in queue have post root along with its index, which is 0, and I have taken a variable result to store the maximum width. So I'm running the loop till the queue is not empty, and basically I'm doing the level order tree traversal. So I have taken in with the queue size, and I'm taking A and B for storing the index of first node at that level, and B for storing the index of the last node at this level. Okay, so this for loop is traversing the current level. So, so I'm taking out the node one by one. I've taken out the node and taken the index and popped it from the queue. And I'm checking, okay, if the node has left child or not. If it is having left child, then I'm pushing the node along with the index, which is 2 for left child, 2 into idx plus 1. IDX is the basically the index of the parent. So yeah, for same for the right child. I have checked whether the right child exists. If it exists, I have pushed the right child along with the index 2 into IDX plus 2. And for storing the first node index in A, I have checked whether I equal to 0. If I is 0, then this index is of the first node. So I have stored it into A variable. And if I equal to n minus 1, then I have stored the index in B. And after traversing the level, I'm calculating the width, which is B minus A plus 1, as we discussed. And I'm maximizing my result. So here I have used long because the question is like that. Uh, it may be means doing a multiplication will give the larger number. So I have used long. So let's run this code. Yeah, it is passing all the given test case. Let's submit it. Yeah, it passed all the given test cases. Thank you for watching. Do like, share, and subscribe.